Okay, today we're going to be looking at geometric series. So here's your formula for geometric series. So when you hear the word series, the only difference is we're looking at the sum now of a geometric sequence. So here's a geometric sequence. We're going to apply this formula. We know the first term. We know n. We don't know r, so we have to figure out what r is first. So we're going to look for the pattern here. I can see this is multiplying by 2. So that means our r is 2. Okay, now we have everything we need. We have a1 here, we have n equals 6, we have r equals 2. We're going to plug it in. So our sum for 6 terms, I guess that should be a 6. First term is 100. 1 minus 2 to the 6th over 1 minus 2. So you're going to plug this into your calculator. You're going to get 2 to the 6th equals, so you got 1 minus 64 times 100 over negative 1. So 100 times negative 63. It's negative 6,300 over negative 1. So it's 6,300. So when you add those all up, they're going to add up to 6,300. So again, you just need your first term, your rate of change, and your n, number of terms. Okay, next thing you're going to have to figure out is if the series converges or diverges. So if it diverges, remember your growth rate is going to be bigger than 1, just like when we did exponents. If your growth rate is increasing, your sum is going to be infinity. If it's decreasing or if it converges, then you can figure out your sum. So pretty much, if ignoring the sign, if it's less than 1, you're going to converge. And if your rate of change is greater than 1, so there should be no equal sign here. If your rate of change is greater than 1, then it's going to diverge. Okay, so if it diverges, you can't find the sum unless you have the number of terms. If it converges, you can always find the sum even if it goes up to infinity. Okay, so when you converge, this r to the n ends up becoming 0. So then your formula just becomes this as you go to infinity. A1 over 1 minus r. Right? So the r to the n goes away. It's pretty sloppy. Okay. All right, let's solve some. Okay, here's our next problem. We don't know how many terms there are. So if the r is less than 1, then we can use this formula to find the sum. If the r is greater than 1, your sum is going to go to infinity. Okay, so we're going to figure out the sum first. I'm going to use the old formula, which was an equals a1 rn minus 1, so that we can figure out what r is. Okay, I'm going to scoot up. So in this case, I'm going to use a2 here and a1, right? So for a2, so I'm going to use n equals 2 in this example. So a2 is 96, a1 is 120. R we don't know. N is 2 because we're using the second term here that we're evaluating. So we got 2 minus 1 is going to give me 1. Right, so I can divide here 120 to both sides, and I'm going to be left with R equals 96 over 120. And I'm going to use my calculator to simplify. We got 4 over 5. Okay, so now we know this R is less than 1, so it's going to converge. We're going to use this formula. So we need A1 is 120. 1, R is 4 over 5. So that's all you need. You're going to plug this into your calculator. Let me pause. Okay. So in this case, I got 1 minus 4/5 is 1/5. And then you keep change and flip, you're going to get 600. So if your R is less than 1, all you need is the first term and your R, and you can find the sum.